The universe possesses a memory that is as long as it is cold, and in the deep stillness of the void, nothing ever truly disappears without leaving a trace of where it once belonged. We often think of the stars as permanent fixtures, yet they are more like embers drifting in a vast, dark cathedral, governed by laws that are as indifferent as they are absolute. Tonight, we find ourselves drifting toward the very edges of the observable horizon, peering into a region of space so distant that the light we see has traveled for over 10 billion years to reach our eyes. In this remote corner of the cosmos, the airless silence is heavy with the weight of ancient history, and the landscape is one of shimmering gas and gravitational tides. It is here that we encounter a celestial anomaly known as JO201, a galaxy that looks less like a spiral of stars and more like a creature from the deep ocean, trailing long, ethereal tentacles behind it as it falls through the darkness. To understand the nature of this Jellyfish galaxy, we must first understand the life of the stars that inhabit it. These stars were born in a time when the universe was young and crowded, yet even then, the scale of space was almost impossible to comprehend. Imagine a quiet afternoon in a small, dusty library, where the only sound is the rhythmic ticking of a grandfather clock in the corner. The smell of old parchment and beeswax fills the air, and a single shaft of sunlight illuminates dust motes dancing in the stillness. This is the baseline of existence for a galaxy, a slow, methodical rotation that lasts for hundreds of millions of years. But for JO201, that peace was shattered by the invisible pressure of the environment it chose to enter. As we watch it now, we are seeing a tragedy in slow motion, a cosmic entity being stripped of its very lifeblood as it plunges into the heart of a massive galaxy cluster. The investigation of this distant traveler reveals a process that astronomers call ram pressure stripping, a term that sounds violent, but, in the vastness of the vacuum, looks like a delicate unraveling of silk. As the galaxy moves through the hot, thin gas that fills the space between clusters, that gas acts like a wind, blowing against the galaxy's own internal reservoirs of hydrogen. It is not long after this encounter begins that the galaxy starts to bleed. The long, glowing trails we see, the tentacles of the jellyfish, are actually streams of gas and newborn stars being ripped away from the main body. They are ghostly reminders of what the galaxy used to be, stretched out across hundreds of thousands of light years like the wake of a ship on a midnight sea. According to the data gathered by our most sensitive telescopes, these trails are among the most distant and oldest ever observed, challenging our understanding of how such structures could survive the turbulent youth of the universe. By the next morning of cosmic time, these trails will have faded, but for now they glow with a haunting, bioluminescent light. The presence of these stars in the tails tells us that even as the galaxy loses its grip on its materials, life, in the form of stellar birth, persists in the most unlikely of places. There is a certain stillness in the way these structures hang in the void, a testament to the fact that even in a universe defined by motion and change, there are moments of profound, frozen beauty. We can almost feel the chill of the intergalactic medium, a temperature so high it is paradoxical, yet so thin it feels like nothing at all. The contrast between the warmth of the star-forming regions and the absolute zero of the surrounding space creates a tension that defines the very shape of JO201. Would later observations confirm that this galaxy is a rarity, or perhaps a glimpse into the fate of many others? The evidence suggests that the universe was once a much more crowded and chaotic place, where such jellyfish were perhaps more common than they are today. As the investigation continued, it became clear that the gas being stripped away is the very fuel the galaxy needs to create future generations of stars. Without it, the galaxy will eventually go dark, becoming a red and dead relic of its former self. This process was identified as a key driver in the evolution of the cosmos, a way for the environment to dictate the destiny of the inhabitants within it. It is a reminder that nothing exists in total isolation. Even a galaxy, with its billions of suns, is subject to the winds of the greater whole. The horizon of our understanding is constantly shifting, moving further back into the shadows of the early universe. In the case of JO201, we are looking at a snapshot from a time when the first great structures were still finding their footing. The heavy silence of the night remains unbroken as we contemplate the distance between us and this ghostly trail. We are separated not just by miles, but by the very expansion of space itself. Yet there is a comfort in the distance. The events we are witnessing happened so long ago that the stars we see may have already burned out, leaving only their light to tell the story of their journey. It is a retrospective calm, a way of looking at the storms of the past from the safety of a quiet, darkened room. As we linger on the image of those drifting trails, we might imagine the smell of a rain-drenched forest, or the soft texture of a wool blanket pulled tight against the evening chill. These mundane anchors keep us grounded, while our minds wander through the light years of the jellyfish's wake. The investigation of such distant phenomena allows us to unwind the complexities of the early universe, bit by bit, until the grand design begins to emerge from the fading shadows. It is a process of deep reflection, a chance to see the universe not as a collection of objects, but as a living, breathing history of motion and light. Not long after we first identified these ghostly trails, we began to realize that the universe is far more interconnected than we once believed. The trails of JO201 are not just debris. They are bridges between the galaxy and the cluster, threads in the cosmic web that hold everything together. According to the police report of the stars, the spectral signatures and gravitational maps, the galaxy is moving at thousands of miles per second, yet in our view, it appears perfectly still. This stillness is the ultimate illusion of the midnight sky, a gift of perspective that allows us to find peace in the face of incomprehensible power. By the time the last echoes of this story fade, the stars of the Jellyfish galaxy will have completed their long descent into the cluster's heart. Their light will continue to travel, crossing the vast, empty gulfs of space until it reaches another observer in another time. For us, the journey is one of quiet appreciation for the endurance of beauty in a landscape that is often harsh and unforgiving. The investigation is complete for now, leaving us with the image of a galaxy that refused to go quietly into the dark, leaving behind a trail of light to guide us through the deepest reaches of our own curiosity. The danger of the void is a thing of the distant past, a historical tragedy that has played out in the silence of the ancient heavens. You are safe here, in the warmth of the present, where the only thing moving is the slow, steady rhythm of your own breath. The stars of JO201 are billions of years away, their struggles finished, their story told. As you drift toward your own horizon of sleep, remember that even the farthest reaches of the universe are bound by the same quiet laws that govern the embers in a fireplace or the ticking of a clock. The night is vast, but it is also a place of rest, and you are exactly where you need to be. In the vast, silent theater of the cosmos, there is a certain rhythm to how things grow, much like the slow, deliberate unfurling of a fern in a damp forest. We often think of the universe as a place of chaotic explosions, but when we look at the farthest edges of what is visible, we find instead a process of gentle, persistent change. Imagine, if you will, a galaxy not as a rigid disk of metal and fire, but as a soft, translucent creature drifting through a dark, pressurized ocean. This is where our understanding of the Jellyfish galaxy begins, at the intersection of the immense and the delicate. These structures, known to astronomers as JO201 or similar designations, carry with them long, trailing tentacles of gas and newborn stars that stretch across the vacuum for hundreds of thousands of light years. To understand why these shapes exist, we must look at the environment they inhabit. Within the great clusters of galaxies, there is a thin, invisible medium, a ghostly fog of hot plasma that fills the space between the stars. As a galaxy travels through this fog, it experiences a soft, steady pressure, much like the wind you might feel against your face if you were walking through a quiet meadow at dusk. This pressure does not break the galaxy. Rather, it performs a cosmic metamorphosis. It gently lifts the loose gas from the galaxy's edges, pulling it backward into the wake of its travel. Within these trailing ribbons of mist, something miraculous happens. The gas cools, settles, and begins to glow with the soft, blue light of infant stars. These are the celestial nurseries, born not from internal collapse, but from the journey itself. It is a reminder that even in the deepest cold of space, movement creates life, and the very act of moving forward leaves a trail of light behind. These trailing stars are like the bioluminescence of a deep sea dweller, marking a path through the shadows that will remain long after the traveler has passed. The silence of these distant regions is profound, a heavy, comforting stillness that blankets the mind. As we observe these jellyfish-like forms, we see that they are not struggling against the void, but are instead being reshaped by it into something more complex and beautiful. The gas that once sat still within the galactic center is now a bridge, a glowing umbilical cord connecting the galaxy to the vastness of the cluster. In this way, the galaxy is never truly alone. It is constantly exchanging its essence with the universe around it. This process is slow, taking place over millions of years, a timescale so grand that it makes the worries of a single day seem as fleeting as a shadow on a sunlit wall. We find ourselves looking at a portrait of endurance, where the elements of the universe are recycled into new forms of brilliance, drifting through a sea of time that has no shore. As the light from these distant stars finally reaches our eyes, it carries the warmth of a story that ended long ago, yet remains present in the stillness of the night. It is a quiet truth that nothing is ever truly lost in the cosmos. It only changes its shape, becoming part of the larger tapestry that we are all woven into. The pressure that shapes the Jellyfish galaxy is the same pressure that guides the clouds across our own sky, a testament to the interconnectedness of all things, from the smallest grain of sand to the most distant nebula. We are observers of a grand, slow-motion ballet where every movement is purposeful and every light is a beacon of peace. We are taught that galaxies are island universes, self-contained and serene, but tonight we have found a wanderer that is bleeding its soul into the void. This observation begins with a simple truth about the nature of persistence. In the quiet hours of the night, we often think of the stars as fixed points, unchanging and resolute against the blackness of the sky. Yet, as we look deeper into the history of the cosmos, we find that even the most massive structures are subject to the winds of change. Tonight, our journey takes us to the edges of the observable, to a place where the distance is measured in billions of light years, and the silence is absolute. Imagine, if you will, the gentle landscape of a coastal town, where the fog rolls in from the sea to blanket the cobblestone streets in a soft gray velvet. The air is cool and carries the faint, nostalgic scent of salt and damp earth. In a small cottage near the cliffs, a single lamp burns in the window, casting a warm, amber glow onto the grass. This is the grounded reality of our world, a place of safety and predictable rhythms. But as we lift our gaze from the damp grass and the flickering lamp, we transition from the familiar geography of our home to the biography of a celestial titan known as JO201. JO201 is a galaxy that has spent eons traveling through the vast, empty stretches of space, but it is currently experiencing a transformation that defies our traditional understanding of galactic evolution. It is the farthest Jellyfish galaxy ever observed by human eyes, a title that suggests a certain ethereal fragility. As it plunges into the dense heart of a massive galaxy cluster, it encounters a thick, invisible medium known as the intra-cluster gas. The pressure of this encounter is so great that it begins to strip the life-giving gas away from the galaxy's core, creating long, trailing tentacles of star-forming material that stretch out behind it like the silks of a ghost. These filaments are not signs of a violent end, but rather a redistribution of potential. Within these blue, glowing trails, new stars are being born in the lonely reaches of intergalactic space. It is a cosmic sowing of seeds, a way for the galaxy to share its essence with the void. According to the data gathered by our most sensitive telescopes, these trails offer a unique map of the invisible scaffolding of the universe. They trace the distribution of dark matter, showing us where the hidden forces of gravity are strongest, and how they shape the flow of matter across the eons. Not long after its discovery, the scientific community realized that JO201 was more than just a visual wonder. It was a missing piece of a much larger puzzle. By studying the way its gas is pulled and shaped, we can begin to understand how galaxies matured in the early universe, long before our own sun was a glimmer of heat in a molecular cloud. The investigation into these ghostly trails remains ongoing, but the initial findings suggest a universe that is far more interconnected than we once believed. By the next morning of our cosmic history, these stars will have settled into their own long, steady glow, lighting up the darkness in places where we thought nothing could ever grow. As we watch this slow-motion ballet, we find a sense of peace in the knowledge that even in the face of immense pressure, life finds a way to bloom in the most unexpected of places. Would you like to explore the specific chemical signatures found within these trailing star nurseries and see how they compare to the elements that make up our own world? The transformation of a standard spiral into a celestial phantom is not a sudden event, but a process of gradual, elegant erosion that spans hundreds of millions of years. We must imagine the galaxy not as a solid object, but as a delicate collection of billions of stars and vast, billowing clouds of cold gas, held together by the gentle tether of gravity. As this collection begins its long descent into the heart of a massive galaxy cluster, it encounters an invisible barrier known as the intracluster medium. This is a sea of superheated plasma, glowing at temperatures of millions of degrees, filling the immense voids between galaxies. While this medium is incredibly thin by earthly standards, the sheer velocity of the falling galaxy, traveling at thousands of kilometers per second, turns this thin mist into a formidable headwind. This is the onset of ram pressure stripping, a cosmic phenomenon that acts like a relentless wind blowing through the branches of a tree in autumn. At first, the outermost edges of the galaxy begin to feel the pressure, where the gravitational hold is weakest and the gas is most diffuse. We see the hydrogen gas, the very lifeblood of future stars, start to lag behind the stars themselves. Because the stars are dense and compact, they sail through the hot plasma relatively unaffected, like pebbles dropped into a stream. But the gas is different. It is buoyant and expansive, easily caught by the current of the intracluster medium. Slowly, the gas is pushed out of the galactic disk, forming the first faint wisps of what will become the jellyfish's tentacles. These trails are not empty. They are rich with the raw materials of creation. Within these displaced clouds, the pressure of the collision actually triggers the birth of new stars in a final, brilliant spark of defiance. These stars are born in the wake of their parent galaxy, destined to spend their lives drifting in the lonely, dark reaches of intergalactic space, far from the glowing spiral that gave them life. We observe these orphan stars as bright blue knots of light, illuminating the long, ghostly trails that stretch out for hundreds of thousands of light years behind the galaxy's core. As the stripping continues, the galaxy's appearance begins to change fundamentally. The vibrant spiral arms, once defined by their rich gas content and active star formation, start to fade and blur. The galaxy becomes a quenched system, a hollowed-out shell of its former self. It is a transition from a world of active creation to one of quiet, starlit reflection. The process is a reminder of the immense scales of time and force at play in our universe, where even the most massive structures are subject to the transformative power of their environment. By the time the galaxy reaches the densest parts of the cluster, it may have lost nearly all of its gas, leaving behind a tranquil, spherical collection of aging stars. The trails, once so bright and full of new life, eventually dissipate into the surrounding plasma, becoming part of the larger cosmic tapestry. This cycle of stripping and quenching is a fundamental part of how the universe evolves, turning young, energetic spirals into the mature, silent giants that populate the centers of the great clusters. We find a quiet comfort in this progression, seeing it not as a loss, but as a necessary change in the long, unfolding story of the cosmos. To understand the nature of these celestial phantoms, we must first reconcile with the idea that space is never truly empty. We often imagine the gaps between galaxies as a perfect, silent vacuum, a void where nothing exists to hinder the movement of a traveling star. Yet, as we look deeper into the heart of massive galaxy clusters, we find a medium that is as tactile and resistant as the deep red waters of our own terrestrial oceans. Imagine, if you will, the experience of a deep-sea diver descending into a high-pressure trench. As they sink further into the abyss, the weight of the water above begins to press inward from every direction. The further they go, the more the medium resists their movement, a heavy, invisible hand pushing back against their descent. This is the exact environment a galaxy faces when it begins its long fall into the center of a cosmic cluster. The space between galaxies in these regions is filled with the intracluster medium, a vast, diffuse sea of hot, ionized gas. While it is incredibly thin by earthly standards, the sheer velocity at which a galaxy travels, millions of miles per hour, turns this thin gas into a formidable barrier. As a galaxy falls into a dense cluster, it encounters this hot, ionized gas which exerts a pressure so immense it physically peels the cold hydrogen gas away from the galactic disk. This process, known to astronomers as ram pressure stripping, is the cosmic equivalent of a gale force wind blowing the petals off a flower. The galaxy's own gravity, which has held its gas in a tight, nurturing embrace for billions of years, is simply no longer strong enough to compete with the external force of the cluster. At the time, the galaxy begins to leave behind a trail, a shimmering wake of gas that can stretch for hundreds of thousands of light years. These are the tentacles that give the Jellyfish galaxy its name. According to the laws of fluid dynamics, the gas is pushed backward, forming long, wispy filaments where new stars are often born in a final, frantic burst of creation. We see these blue, sparkling knots of star formation as a testament to the galaxy's resilience, even as it is being unmade. It is a slow, methodical transformation that would later leave the galaxy quenched, a term used by scientists to describe a state where the fuel for new stars has been completely exhausted. Not long after the stripping begins, the galaxy's appearance changes fundamentally. it is not losing itself, it is transforming. The galaxy is shedding its heavy cloak of gas to reveal the ancient, shimmering skeleton of stars beneath. This transition evokes a sense of intellectual awe, a realization that even the supposed emptiness between galaxies is a physical, tactile force capable of reshaping the largest structures in the universe. By the next morning of cosmic time, the once vibrant spiral will become a ghost of its former self, a smooth, red collection of aging stars that no longer breathes the cold gas of creation. The investigation into these shapes reveals a profound stillness in the aftermath. The pressure of the intracluster medium is a reminder that the universe is interconnected, that the movement of one body is always felt by the medium through which it travels. We find ourselves drifting through these concepts, watching as the horizon of a galaxy's life fades into a new, quieter form. The heavy gas, once the lifeblood of the system, is left behind in the deep shadows of the cluster, drifting away like smoke in a windless room. This process was found to be universal, a common fate for any traveler daring to enter the high-pressure heart of a galactic city. As we observe this shedding of the old self, we are reminded of the cycle of change that governs all things, from the smallest atom to the grandest island of stars. The galaxy remains, but it is lighter now, unburdened by the material of its youth, drifting toward a peaceful, starlit retirement. While the shedding of gas is a universal process in the crowded centers of the universe, there is one particular traveler that has captured our collective wonder more than any other. We find ourselves looking toward a distant coordinate in the southern sky, a place where the darkness is thick and the light has traveled for billions of years to reach us. Here we encounter JO201. It is not merely a galaxy, it is a record breaker, a cosmic ghost that stands as the farthest jellyfish galaxy ever observed by human eyes. At such immense distances, the universe begins to feel less like a collection of objects and more like a vast, unfolding history book, where every flicker of light is a sentence written eons ago. In the quiet observation rooms of our great observatories, the discovery of JO201 felt less like a sudden flash and more like the slow realization of a miracle. To see a galaxy at this distance is difficult enough, but to see one in the very act of being dismantled is a triumph of patience. We are moving our focus now from the microscopic level, the individual atoms of hydrogen being pushed by invisible winds, to a scale that truly defies the human imagination. JO201 is trailing a wake of stolen material that stretches for over 200,000 light-years. To put that in perspective, our own Milky Way is a mere 100,000 light-years across. This single galaxy is dragging a tail of stardust and gas behind it that is twice as long as the entire galaxy we call home. Imagine dragging a brush soaked in blue light across a canvas of absolute black, leaving a trail of wet, glowing ink that refuses to dry. This is the visual reality of JO201. The ink is actually a nursery of new stars born from the chaos of the stripping process. As the cold gas is ripped away, it collapses under its own weight, igniting into brilliant blue suns that mark the path where the galaxy once stood. These stars are orphans, born in the lonely void of intergalactic space, far from the protective spiral arms of their mother galaxy. They glow with a fierce, short-lived intensity, illuminating the ghostly trail like lanterns hung along a dark, winding road. The sheer scale of this displacement is a testament to the violence of the cluster environment. Yet from our distant vantage point, it appears as nothing more than a delicate, wispy thread. There is a quiet pride in the halls of science when we consider the tools used to find this needle in the cosmic haystack. To see a ghost this far away, we had to build eyes that could look through the very dawn of time. By combining the infrared vision of the James Webb Space Telescope with the ground-based power of the Very Large Telescope in Chile, we have managed to pierce the veil of distance. These machines, built with glass and gold and the dreams of thousands of engineers, allow us to sit by the fire of our own small world and watch the ancient dramas of the deep sky. We have reached out into the dark and found a reflection of our own curiosity, glowing blue and trailing behind a traveler that has been walking for billions of years. Nature has a curious way of repeating its most elegant designs across vastly different scales, from the microscopic pulse of a heart to the silent drift of a galaxy. When we look at the deep-sea inhabitants of our own world, we see creatures that have mastered the art of moving through a medium that is both supportive and resistant. The jellyfish, with its translucent bell and trailing filaments, exists in a state of constant negotiation with the pressure of the ocean. It is a creature of the current, defined by the way it pushes against the water and the way the water pushes back. We find that the universe itself possesses a similar quality, a hidden thickness that only reveals itself when something moves through it with enough conviction. The space between galaxies is often described as a vacuum, a hollow void of nothingness that offers no resistance to the travelers within it. However, as we observe the journey of JO201, we begin to understand that this is a polite fiction. The intracluster medium, that thin veil of superheated gas that fills the gaps between the stars of the Abell cluster, behaves with the distinct characteristics of a fluid. It has a density, a temperature, and a measurable pressure. To a galaxy moving at millions of miles per hour, this supposedly empty space feels as thick and visceral as the salt water of the Pacific. It is here, in this invisible sea, that the physics of the very large begins to mirror the physics of the very deep. In the quiet laboratories where physicists map the movement of these celestial bodies, they speak of the Reynolds number. It is a mathematical expression used to predict how a fluid will flow around an object, determining whether the path will be smooth and predictable or chaotic and swirling. In the case of JO201, the Reynolds number suggests a transition from laminar to turbulent flow. As the galaxy plunges into the cluster, the gas it encounters does not simply step aside. Instead, it ripples and breaks. It creates the tentacle structures we see in the H-alpha emission lines, long ribbons of glowing matter that trace the wake of the galaxy's passage. These are not merely trails of dust. They are the physical records of a cosmic struggle, the turbulent eddies of a giant moving through a resisting medium. We might imagine for a moment the slow-motion footage of a Chironex fleckeri, the box jellyfish, as it pulses through the darkened depths of the Australian coast. Its body is a soft curve of light, and behind it, its stinging cells trail in long, delicate wisps that respond to every shift in the tide. Now, if we look to the heavens, we see JO201 doing the very same thing. The galaxy is a jellyfish, pulsing with the slow, ancient rhythm of gravity, trailing its own stinging cells of newborn stars into the gravitational current. The H-alpha light we detect is the signature of hydrogen gas being compressed and ignited, forming stellar nurseries in the very place where the galaxy is being torn apart. There is a profound intimacy in this realization, a sense that the universe is not a cold, sterile gallery, but a living, breathing environment with a thickness we can almost feel. The same laws of hydrodynamics that govern the wake of a ship or the flight of a bird are at work on a scale of hundreds of thousands of light years. The universe is not just a place where things happen. It is the substance through which they happen. We are part of a grand, interconnected plumbing of light and gas, where the birth of a star in a distant cluster follows the same fluid logic as a bubble rising to the surface of a dark, still pond. As we watch these ghostly trails, we see that the galaxy is shedding its weight to pay for its passage. The gas that once sat comfortably within its spiral arms is being stripped away, left behind like a memory of where the galaxy once was. This process, known as ram pressure stripping, is the cosmic equivalent of a heavy wind blowing through a forest, carrying away the leaves but leaving the branches bare. Not long after the galaxy enters the densest part of the cluster, the pressure becomes so great that the very essence of the galaxy begins to bleed into the void. By the time the investigation into these structures was completed, it became clear that the Jellyfish moniker was more than just a visual coincidence. It was a description of a fundamental state of being. To exist in the universe is to be in motion, and to be in motion is to interact with the hidden currents of the cosmos. The silence of the night remained unbroken as the telescopes in the high deserts of Earth continued to sip the faint light of JO201, recording the slow dissolution of a giant. It is a reminder that even the largest structures in existence are subject to the gentle, persistent pressure of the medium they inhabit. The investigation into the wake of JO201 identified these trailing filaments as regions of intense star formation, where the pressure of the ocean actually sparks new life. In the wake of destruction, there is creation. The galaxy leaves behind a path of diamonds, a glowing breadcrumb trail that tells the story of its descent. According to the data, this process will eventually leave JO201 as a red and dead galaxy, its fuel spent, its tentacles vanished, drifting as a ghost through the cluster. But for now, it remains a magnificent traveler, a celestial marine light dancing in the dark. The stillness of the observation deck is a comfort as we contemplate these distances. We are safe here, separated from the turbulent wake of JO201 by a gulf of time and space that ensures our own sun remains undisturbed. The heavy pressure of the cluster gas is a world away, a historical tragedy that we are privileged to witness from the warmth of our own shores. We can see the fading edges of the galaxy's reach, the way the light softens as the gas becomes more dilute, and we can appreciate the heavy beauty of a system that is giving itself away to the universe. As the shadows lengthen across the control rooms of the great observatories, the scientists move with a quiet reverence. They understand that they are looking at the pulse of the universe itself. The horizon of our knowledge expands with every photon collected, every ripple in the cosmic fluid accounted for. The universe is deep, it is thick, and it is full of a strange, rhythmic life that mirrors our own. We find ourselves drifting now, moving away from the violent heart of the cluster and toward the softer edges of the story, where the turbulence begins to settle and the silence returns to its natural state. The transition from the dense, crowded center of the galaxy cluster to the sparser outskirts feels like moving from a bustling city into the quiet, fog-laden countryside at dawn. Here the intergalactic medium is less of a thick soup and more of a delicate mist, yet it remains the primary sculptor of the Jellyfish galaxy's long, ethereal limbs. We find ourselves observing a process of dilution, where the initial violence of the galactic collision begins to soften into a rhythmic, steady erosion. The gas that once lived comfortably within the galaxy's gravitational embrace is now being teased away, thinned out by the sheer persistence of the wind it travels through. It is a slow, methodical peeling of layers, much like the way a gentle but constant stream of water might eventually smooth the jagged edges of a stone over 1,000 years. The sensory details of this region are characterized by a profound sense of stretching. If we were to stand on a planet within one of these trailing tentacles, the night sky would not be a uniform velvet, but a streaked canvas of glowing hydrogen, shimmering with the ghosts of stars that haven't yet been born. We might notice the smell of ozone and the faint, metallic tang of ionized particles, a sharp contrast to the warm, dusty scent of a stable galactic core. The sound here, if sound could travel, would be a low-frequency hum, the vibrational resonance of magnetic fields being pulled like taffy across the void. According to the data gathered by our most sensitive instruments, This medium density phase is where the galaxy loses its primary identity, shedding its heavy cloak of gas and becoming something lighter, more skeletal, and strangely more beautiful. As the morning light begins to touch the edges of the horizon back on our own world, we can reflect on the fact that this dilution is not an end, but a transformation. The stars that eventually ignite within these fading trails will live out their lives in an isolation we can scarcely imagine, far from the gravitational anchor of their parent galaxy. The investigation into these ghostly trails has shown that the matter being stripped away will eventually settle into the vast emptiness between clusters, contributing to the thin, warm, hot haze that permeates the cosmos. By the next morning of cosmic time, the Jellyfish galaxy will have passed through this gauntlet, leaving behind a trail of stardust that serves as a permanent map of its journey. The danger of the high-pressure environment is now a memory, and the galaxy moves forward into a state of quiet, drifting equilibrium, reminding us that even in the face of immense pressure, there is a graceful way to let go. We are safe in the knowledge that these celestial events, while grand in scale, follow a predictable and peaceful path towards stillness. We find ourselves now in a space of profound, rhythmic stillness. The heavy theoretical weight of the descent begins to lift, replaced by a quiet observation of the aftermath. If you were to look out from the bridge of a vessel drifting in the wake of such a giant, you would see something that defies the logic of destruction. There is a particular brilliance to the sight before us. Within those long, ghostly ribbons of gas, the trailing tentacles of the Jellyfish galaxy, there are clusters of light that appear like small, glowing blue berries scattered across a dark, velvet field. These are not old stars being dragged away from their home. They are new. They are vibrant. They are the youngest children of a dying parent, ignited by the very friction that sought to pull the galaxy apart. To understand this, we must imagine the sensory reality of this sting. Imagine the touch of the intracluster medium, a cold, crushing grip that surrounds everything. It is a pressure so immense it should, by all accounts, extinguish life. We feel a strange sense of proprioception here, the sensation of being pulled backward by an invisible tide while our momentum carries us forward at millions of miles per hour. It is the feeling of resisting a wind that is slowly, inevitably, peeling away our outer layers. You might think the tail is a graveyard. You might look at those drifting clouds of hydrogen and see only the remains of a once great spiral. But strangely, it is a nursery. In the wake of the galaxy's death, new stars are being born where they were never meant to exist. In the deep isolation of the intergalactic void, far from the safety of the galactic core, the gas becomes dense enough under the pressure of the sting to collapse. It is a moment of deep philosophical wonder. We see life arising from the aftermath of a violent collision. The very force that stripped the galaxy of its future has provided the catalyst for a new generation of light. These stars will spend their entire lives in the lonely stretches between the galaxies, drifting as orphans in the dark, yet they shine with a fierce blue intensity. It reminds us that even when things seem to be falling apart, when the pressure is at its peak and the familiar is being stripped away, there is a creative power in the transition. The sting is not just an end, it is a beginning, a luminous trail of resilience left behind in the cold, quiet deep. The investigation of these tales shows us that the universe does not waste its materials. What was once part of a home is now the foundation for something new, an identification of life in the most unlikely of places. According to the data we have gathered, these nurseries will continue to glow for millions of years, long after the parent galaxy has faded into the shadows of the cluster. We are safe in this observation, watching the slow, beautiful unfolding of a process that turns a tragedy into a masterpiece of light. By the next morning of cosmic time, these blue berries will have matured, casting their glow into a horizon that was once entirely empty. Not long after, the stillness will return, but the stars will remain as a testament to the journey. The investigation of the Jellyfish galaxy, JO201, reveals a curious paradox of cosmic architecture, where the very forces that seem to tear a system apart are the same ones that provide its hidden structure. We travel now into the heart of this luminous traveler to understand the silent partner in this dance. Imagine for a moment that you are standing on a planet tucked deep within the central disk of JO201. You look up at the night sky and you find a horizon split in two. To your left, the sky is a velvet void, a deep and settling blackness where the stars have been swept away by the pressure of the cluster. But to your right, the view is transformed into a river of blue fire. Thousands of new suns are igniting in a long, trailing wake that stretches for hundreds of thousands of light years. It is a sight of immense power, yet from your vantage point, the ground beneath your feet feels perfectly still. This stability is not an accident of chance, but the work of a phantom. According to the laws of visible matter, a galaxy under such intense pressure should simply dissolve. The hot winds of the Able 85 cluster reach speeds of millions of miles per hour, acting like a physical hand trying to strip the stars from their home. Yet the core of the galaxy remains defiant. Gravity holds. Gravity pulls. It is the invisible thread, the loom upon which the jellyfish is woven, holding the primary stars in place even as the cosmic wind tries to blow the gas away. This gravitational anchor is provided by dark matter, a substance we cannot see, touch, or measure directly, yet its presence is felt in every curve of the galaxy's spine. In the purple-hued simulations of the cosmic web, we see these dark matter filaments acting as the currents of a great, invisible ocean. They provide the scaffolding, the heavy, unyielding skeleton that prevents the jellyfish from being completely scattered into the dark. At the time of its discovery, astronomers noted that while the gas is easily pushed into those haunting, ghostly trails, the dark matter halo remains largely unmoved. It is a heavy, silent guardian. We might think of it as a deep-rooted tree in a hurricane. The leaves and the blossoms, the gas and the dust, may be ripped away to form the trailing stingers, but the trunk remains firm. This invisible hand ensures that even as JO201 loses its breath, it does not lose its soul. The stars already formed stay nested within the dark matter's embrace, while the stingers of the tail are left to fend for themselves in the wilderness of the intergalactic medium. By the next morning of the galaxy's life, the dark matter will still be there, a cold and quiet weight that keeps the remnants of the galaxy together. As the investigation continues, we see that the interaction between the seen and the unseen is what gives the jellyfish its shape. The heavy pressure of the cluster is the sculptor, but dark matter is the stone. Without this hidden mass, the blue fire we see in the sky would be nothing more than a fleeting spark, quickly extinguished by the void. Instead, it becomes a long, slow-burning legacy. The stillness of the galaxy's core, protected by its invisible shield, allows us to watch this process with a sense of retrospective calm. We are safe in the knowledge that while the wind is fierce, the anchor is deeper still. The journey of JO201 is a reminder that even in the most chaotic regions of the universe, there is a fundamental order, a drifting peace that guides the stars through the shadows. The horizon remains wide, and the heavy pull of the deep ensures that the story of the farthest jellyfish galaxy is one of endurance, written in the ink of the invisible and the fire of the new. The universe, in its vast and silent wisdom, suggests that nothing is ever truly lost, merely rearranged within a grander design. Beyond the individual struggle of a single galaxy, we find ourselves observing a much larger architecture, a gathering of giants known as the Able cluster. From this distance, the frantic stripping of gas and the trailing ribbons of new stars soften into a collective motion, a rhythmic pulse that guides every inhabitant toward a shared destiny. We are no longer looking at a solitary traveler, but at a living, breathing organism of light and gravity. The cluster itself acts as a cosmic cradle, a dense and ancient heart that beats with the steady thrum of billions of years of history. As we adjust our perspective, the scale shifts from the frantic to the foundational. The cluster feels like a heavy, velvet weight in the center of the dark, pulling everything toward its warm, dense heart. This is not a violent tug, but a slow, inevitable embrace, a homecoming for the wandering islands of stars that have drifted through the void for eons. The gravity here is thick and comforting, a physical presence that anchors the soul. We watch as galaxies are fed into this center, moving along invisible currents like autumn leaves caught in a deep, slow-moving river. There is a profound sense of existential safety in this sight, the realization that no matter how far a galaxy may wander, it belongs to a larger structure, a family of light that ensures it will never be truly alone. As we move deeper into the cluster, the light begins to change, softening into a golden haze of ancient memories. The harsh, blue brilliance of young stars gives way to the amber glow of the elders, those who have already completed their journey and now rest in the cluster's core. The transition is seamless and quiet. The vacuum of space, once cold and indifferent, now feels occupied by a gentle pressure, a sign that we are entering a place of sanctuary. According to the laws of these dynamics, the movement toward the center is a refinement, a process where the chaotic energy of the outskirts is distilled into the steady, unwavering radiance of the interior. By the next morning of cosmic time, the Jellyfish galaxy we once followed will have shed its trailing ghosts and found its place among the others. The investigation of these movements reveals a beautiful irony. The very forces that seem to strip a galaxy of its life are the same forces that deliver it to its final resting place. The journey home is long, and the path is marked by the loss of what was once familiar. But the destination is one of permanence. In the stillness of the cluster's heart, the shadows are not to be feared. They are merely the spaces between the stars, the quiet intervals in a long celestial lullaby that continues to play long after the fires of the journey have faded into peace. You are safe here within the architecture of the deep, where every light is accounted for and every journey ends in a quiet, golden rest.